Okay, so once you've installed the gem and then launched the Glimmer meta sample through the Glimmer samples command, then you should see something like this. Can you guys all see this? Yeah, so basically this is an app that lists all the samples on the left side. And it shows you the code of every sample when you select it on the right side. So I just selected hello text, so it's showing me the code of hello text. I bumped up the font just for this presentation by default, so you guys should, this text should be readable, right, guys? Yeah. Awesome. So yeah, let me show you a few samples just to demonstrate what Glimmer is. I mean, so I just showed you. Let me delete this license code. Doesn't matter, but I just showed you a video that was demonstrating how to do Hello World. So I mean, this is Hello World. I'm going to zoom in to show you what you get. You end up getting a window that has the title Glimmer with a label within it that says Hello World. The nice thing about being able to get something like that with so little code is that this encourages people to learn programming in a very friendly way. A lot of people are discouraged by programming because if you want to show any kind of graphical user interface with web libraries, you have to build something very complicated using the simplest web framework out there, Rails. Rails is one of the best frameworks out there, and yet it's still a lot more complicated than this. Here I can just, if I delete all of this code and type window, by the way, window is an alias for shell. In SWT, they use the word shell to describe Windows, but I provide an alias for it, which is window, and Glimmer DSL for SWT. And if I type just window open, it opens a window, which is awesome. That's the quickest way to get from code to graphical user interface, I believe, in the world. I don't think there's a better way than this because of Ruby, thanks to Ruby. And then if you want to do, customize it a little bit, you just open a Ruby block. But given that we're operating within a DSL, this DSL works kind of like like HTML, but within the Ruby language. So basically, now we're within the window, so we can add properties. So I can add a property of text, for example, Glimmer, and launch it. And now we see here Glimmer. But then I can, for example, I can add a minimum size of 640 by 480. Now we have a window of 640 by 480, so this is more of a proper window now. And then I can add a label, and I can say here text hello world, and let's add a font. Well, I mean, let's launch it first. So it does say hello world here, but it's very tiny. So let's make it bigger. So I can just add a font and give it a height of whatever, let's just say 60. And boom, or maybe make it even bigger, 120. There you go. So Glimmer DSL for SWT helps you build apps very quickly. And this is just the simplest example. But what if we were to build a more serious app that involves more complex widgets, not just a label? Let's just say we want a table. So a table is basically one of the most important widgets in business applications. Almost all business applications will use tables to summarize data and list them and allow you to filter by queries as well as sort the data. So if you want that, I'm going to launch the Contact Manager app. And I won't get into the code yet because I have not explained to you the Glimmer DSL rules yet. We'll get into that in a second, but this is a more sophisticated app that uses data binding. Glimmer DSL for SWT supports declarative data binding, which enables you to write the simplest code possible to populate widgets with data. So this table is populated with data using data binding. It supports sorting out of the box. I can do filtering. So if I want to search for last name Smith and hit find, now it finds me all the Smiths. I can, if I want, let's do list all again and then add a new user like John Doe. Whoops. And create John Doe. There you go. John Doe got created and added to the table. So I get all of that functionality by using the Glimmer DSL for SWT. So this is a more sophisticated real app that demonstrates how real business apps could be built with this. Let's go into something even more complex. So suppose I want to use non-native widgets now. I already mentioned you guys could do non-native things as well. I'm gonna launch a game. So I have a number of games. I have Snake, I have Quarto, I have Tetris, I have Tic-Tac-Toe, but I just launched Tetris. So I mean, this is just demonstrating that using the same principles of using a DSL as well as using data binding, declarative data binding, you can even build games if you want. And building games this way will result in some of the most minimal code possible for building the game. And I'll show you that in a second. So let me close this for now and get back into the presentation. So we went through Hello World, we went through the Contact Manager, and we went through Tetris. So let's talk about some real world apps that I've built with Glimmer DSL for SWT. So there's this math bowling game that I built for my nieces to help them learn math. It's a game that lets you test your math skills, like what is 14 by 10. For kids, this might be tougher than you think. For us, it's easy. But anyways, it has levels of difficulties. But basically, they'll pretend that if they answer the question, it's as if they made a bowling throw, like as if they bowled basically in a bowling alley. And then they'll get the results. And depending on how far the answer is from the real answer, that's how many pins they knocked, basically. So it's a sort of a educational game, but it's built with Glimmer DSL for SWT because it's a perfect fit. It's a local game. And also Glimmer DSL for SWT enables you to package Ruby code as real native apps. Like on the Mac, it would be a DMG file that people can download and install. So I built this game, and my sister installed it, and I had my nieces learn math through it. And they liked it quite a bit. This is another real app that has a Gantt chart. So this is demonstrating some non-native concepts. Like if I want to do a Gantt chart, that's definitely not a native widget. But thankfully, I can reuse any available Java SWT widget in the Java market. So I was able to find a Gantt chart widget for SWT, custom widget, and use it in Ruby very effortlessly. And then I used a table with data binding and then a form with data binding. And that app basically got used by my sister in an interior design, in her interior design work. She's an interior designer. This is Gladiator, which is a code editor that I built in Ruby. I demonstrated it during the last Montreal.rb meetup a few months ago. But basically, it's a code editor that supports syntax highlighting for about 200 programming out of the box 50 programming languages, but I can offer 200 if needed. But it also supports file lookup and a whole bunch of other features that I won't get into right now. But I've been using it as my main editor for the last 2 years, just as a way of educating myself actually on how to build code editors. I found that a very interesting exercise. And every once in a while, somebody mentions to me something that's a missing feature. Like Mark Andre mentioned to me, I don't have dark mode. So the other day I added dark mode to it. So it's pretty cool that I could, augment it and build it very quickly with Glimmer DSL for SWT. This is a programming language for kids. It's called DCR, Draw, Color, Repeat. It's based on Logo. Has anybody here heard of Logo before? Okay. Yeah, I heard of it too, because when I was a kid, actually, it was one of the first programming languages I've used. So I built a Ruby IDE for it using Glimmer DSL for SWT. So you say here, forward 80 pixels, turn right by 45 degrees, repeat 6 times, and then color it yellow, and there you go. We got this hexagon, whatever, octagon shape. So this is another programming language IDE. It's for the bfunge programming language. So I found a Ruby engine in a Ruby gem that lets you basically interpret the bfunge programming language. I simply built an IDE on top of it using Glimmer. This is a Klondike Solitaire. It's like, the good old Solitaire from Windows, but in my opinion, this is nicer, much nicer, because I built it. This is Wordle. You guys know Wordle? Yeah, this is a desktop version of it that lets you play infinitely, unlike the web game that has only one puzzle a day. So I played this a lot when I first built it. I learned a lot building, playing it. This is a metronome that I use. I'm a drummer, by the way, as a hobbyist. I play drums in 2 rock bands. I use this for my training. And it's solid enough. It gives me all the options I need, and it's actually more reliable than my phone metronome. Part of the reason why I built it is my phone metronome got an update one time, and then it ended up with bugs. It wasn't reliable anymore, so I ended up deleting it, and then I built this app in like 10 minutes for the first version. It took me an hour for more improvements, but 10 minutes for the initial version. It was awesome. So what are the GUI DSL basics? How do we get started with Glimmer? So Glimmer aims to be, it has a few goals behind it. One of the main goals is to be declarative and to require the minimum amount of code possible that you could think of. So when you think of something, if I think button, I should be able to just say button, and then I end up with a button. You guys saw that already. I said window, and we ended up with a window. So that's the minimum amount of code possible. Like there's no crazy, like in HTML, usually you have to add crazy, brackets around the HTML tags, and also a closing tag, like so much redundancy. You have to add a closing tag, etc. Or if you're using something like React, you have to do render, and you have to add a lot of JavaScript code and weird hooks and stuff before you get what you want. Here, no, we just declare it. We're using Ruby. Ruby is like one of the most superior languages in the world for declarative programming, and we get it. So we can say button, label, text, radio, shell, meaning window, and there's a whole bunch of widgets that are supported in SWT out of the box. Basically, every native widget out there in operating systems is supported. So I'll get into that later, but that's just an example. The next thing you want to learn, the second thing, is widget arguments. So widgets can optionally receive arguments. So if I want a button that has the text aligned left, I pass it a symbol that says left. In SWT, all widgets have a uniform API that receives something called SWT styles. In Glimmer, instead of passing SWT styles the SWT way, which they require you to pass bit-ord integers, which is something like very crazy low level, you don't have to worry about that. Just use symbols in Ruby. And then if you want to pass multiple of them, you don't have to do bit-oring. You just separate them by comma, and the library will take care of the rest for you. So here I'm saying I want a button that has the flat style with the left aligned text. The third thing you want to know is widget content block. So any widget can be followed by a content block. And since we're operating in a declarative way in a DSL, you don't want to do a do-end like you do in Ruby with multi-line blocks usually, because do-end is imperative. You're saying do till it ends. Here we're being declarative. Think of this more like HTML, except you don't need a closing tag. What you do is you open this curly brace and then you close it, and this is the body of the button. So, and that's the equivalent of a button in HTML. So within the body, you can put properties and you can put listeners. So let's go next. And obviously you can take arguments. So let's start with properties. So properties, if you check out the SWT API, for every widget, there's a big list of properties that you can set. And here, what you do to set them, you don't set them imperatively. So imperatively, the way to do it is you would say button dot set text, and you pass it the text. Here in Glimmer DSL for SWT, we don't want to waste time on that kind of low-level code. Like what you do is just say button, and then you declare the property text, and you pass it the value, and that's it, you're done. You can pass multiple properties, so we have a text here, we have a font here. And not only that, since we're in Ruby syntax, you can, if you need to mix an if-else statement for some piece of logic that you need to have, you can actually mix it with the DSL natively. So unlike with HTML, where you cannot do that, in HTML you have to add a ERB tag in Rails in order to mix logic with it. And also in React, you cannot do that. In order to mix JSX with JavaScript, you have to open curly braces. Here in Ruby, we are in the same language. You don't have to do anything. Just add an if-else statement and it'll work. And I'll show you examples in a minute how to do that. Next, widget content block listeners. So they're basically the observer pattern, and they let you run imperative code. So in the end, eventually, you will need some imperative code to do logic. But usually the GUI structure is declarative. You want to declare what the GUI hierarchy is. You have a window that has a label, that has buttons, etc. But when you're executing logic, when people click a button, then you have to do imperative code. And so this is the point where you actually declare a listener with on underscore, the name of the event. So it's very similar to, say, JavaScript with HTML. But then you say do end. This is the place to do a do end. And that cleanly separates imperative code logic from declarative code. And then here you do what the button should do when you press the button. By the way, the reason I have this here is it's demonstrating, we have a button and we have a window. I'm just trying to give you a visual as well as we're going along, but eventually I'm going to show you the code of that sample. So yeah, listeners could be different types of listeners. You can listen to when the text is modified on a text field. You can listen to when a keyboard button is pressed on a text field. And there's a whole list of listeners that is available in the SWT API docs. The last thing you need to know is widget operations. So when you actually build a widget like a shell or a text widget or a button, you end up receiving back a Ruby object. And that Ruby object does have methods, so you can just invoke operations on it. It basically follows exactly the API of the SWT widgets and the SWT docs. It actually wraps the SWT widgets with Ruby objects. So there are SWT widgets that are created in Java. They get wrapped with Ruby objects, but to you it doesn't matter. You can invoke the same methods on them. JRuby will give you Ruby-friendly versions of all the API methods. So I'll show you what that means in a second. But also behavior is sometimes augmented with smart defaults. So what does that mean? Meaning when you open a shell, usually in any GUI library out there, they tell you not only should you open a window, but you also have to start something called the GUI event loop. At least in SWT that's required. Maybe GTK requires it too, but anyways, you have to start something called the GUI event loop. Here we don't have to do it. It happens automatically for us, so there are smart defaults. But here's an example of operations. So, I already showed one, which is opening a window. So that's why here we say dot open. But also, if I have a checkbox, for example, and I built it, the Ruby object returned is a terms checkbox, and then I can say here dot selection equal true. And this is the clean Ruby way of doing it. And JRuby gives you that automatically. So in Java, the API is actually set selection. So let me show you. You could do it this way too, set underscore selection, or you can even write the Java way, which is set selection camel case. That's how the API was designed at SWT, but JRuby will automatically support the other options for you so that you can just operate the Ruby way and not worry about it. So, that's pretty much it as far as the basics of the GUI DSL. This gives you, all the basics, except data binding, which I'm going to get into in a bit. But before we get there, let's talk about software architecture. So the most common software architecture in desktop applications is MVC, because that's the oldest architecture. It came from Smalltalk MVC, which is one of the oldest GUI libraries out there. I believe it is the first GUI library out there. So in Smalltalk MVC, or MVC in general, the pure version, this is the purest version, you have a view, meaning things that you see on the screen that give you data, a view of information or data. So that could be a text field that is showing you the name of a user, could be a label that's showing you a summary of the total of an order, or it could be a table displaying a whole bunch of rows of information. So this is what a view does. Controller is basically the object that will receive events or interactions from the user in order to mutate the data. So if the user wants to edit the name, they have to submit a new name for the text widget in the text widget. So in order to do that, they have to do that through the controller. Finally, the model will basically embody business rules about the data. So if we have, for example, an order and it has to calculate the total automatically, the model will contain the tax, for example, amount, like the tax percentage, like it has to add 15% to any amount for the order. So the model will embody the business rules. And that's pretty much what MVC is. But a few things to note about MVC, the pure version, which you don't see in Rails, for example, because Rails is a bit different because it's a web interface that's happening through multiple servers. sorry, like a web architecture that's happening through multiple servers. Here, when we're all local and on the same machine, you simply have a view that represents a widget. However, the view, typically in Smalltalk MVC, if you're following it correctly, will observe the model for changes, and as soon as the model changes, it'll update itself. So that way, the model doesn't have to know about the view, but the view knows about the model. So what that means is you can pass the view a person object, and then the view will pick the first name and last name and display them in the text fields. The controller, on the other hand, will observe the view. So it observes it, but then it receives events about view changes. What that means is when a user clicks the button, that's a view change. So that the controller will get alerted that the button got clicked, and then it'll do work. The thing about MVC that makes it so clean is that you should never have the model update the view directly. The view should be observing the model and updating it itself. But also, you should never have the controller manipulate the view directly. It should manipulate the models, and then the view will update itself as the models change. So that will result in the cleanest code possible, usually. And I'll show you examples of that in a minute. So yeah, I mean, examples of model attributes, as far as model update events, attribute changes. So I mean, that's pretty much it. And then here is observing a mouse up event, a key up event on the keyboard, a selection of a list in a list, for example, or table, etc. However, a more advanced graphical user interface pattern that emerged eventually was something called MVP. MVP is just an evolution of MVC. It doesn't really violate it necessarily. Basically, the controller gets replaced with a presenter, and the presenter, what it'll do is it'll do bidirectional data binding. What that means is it'll observe the view for any changes, and when it receives the events, it'll update the model, and then it'll observe the model for any changes, and then when it receives events, it'll update the view. So that way, the view and the model are fully decoupled from each other. You don't want to always do that, but sometimes that is very useful. For example, if I have models that don't care about how to present the models, like if I'm presenting the data on a table, I might want some rows to be colored red and other rows colored green. That information is not model-related information. The business logic doesn't care about that. The business logic might be more about, okay, these rows are delinquent customers, and these rows are, good standing customers, etc. So you would introduce a presenter that abstracts those details out and handle all those details. So that's what an MVP is. So let's start looking into some code examples, because I'm sure that's a lot more interesting than just diagrams. Here's an MVC example with an explicit controller. So in Glimmer DSL for SWT, you have the observe keyword that you can use in the view to observe any attribute on a model for changes transparently. Meaning, if I were to use Java or anything else like C++, whatever, usually you have to go to the model and include a superclass or a super something that makes it observable. And then you can observe its attributes. Glimmer DSL for SWT aims at making that completely transparent so that you as a programmer build the models without worrying about observability. So as long as you have a count equal method and a count reader, meaning an attribute reader and a writer, I can have the view observe the model for any changes to that attribute using Ruby meta programming. So that way, the model code remains as simple as possible. It doesn't even know about the fact that it's being observed by a view. So here we observe a counter for the count. And as soon as we receive the changed count, we actually update the view button text. So this is the MVC, pure MVC. The view is updating itself as soon as the model changes. So that's the first observation I mentioned. And then the second observation is the controller observing the view. So we have an onWidget selected listener. As soon as it fires, there's a controller here that will increment count. So this is how to do it using the MVC way. Now you can do something called implicit controller. Implicit controller is basically the observation here, it stays the same, but here we're not dealing with the controller directly anymore. What we do is we have the view fire an increment method on the model directly. And then as soon as the model changes, this code will fire automatically and the view will update itself. And this block is the controller. This do-end block is an implicit controller in Ruby. So that's one of the niceties of using Ruby, is you can have implicit controllers. When I used Java in the past, you always had to have an explicit controller. You couldn't do this. Okay, here it gets even nicer. Here we're using data binding. You don't even have to observe the model anymore. Now we're doing MVP. Now you just declare the button. So by the way, here I assigned the button to a variable in order to use it here. Here you don't even have to assign the button to a variable. All you do is you take its text property and say, I want one-way data binding. So there's an arrow going to the left side that's saying whenever the count on the counter presenter changes, it'll update the text of the button. And on read of the data, it'll execute a converter. So here it'll convert the value into click to increment value. So here in the GUI, you end up seeing click to increment 12, and then 13, and then 14, and then 15. And on widget selected, all it does is it triggers the increment count method on the presenter, which is playing the role of a controller. Now there's an even nicer option, which is the implicit presenter. So you can even do away with the presenter altogether and just bind the view to the model directly, and the presenter becomes transparent. It's actually as part of the Glimmer framework itself. You don't have to deal with it directly. So here we have a text that's data bound to the model, unidirectional data binding, same thing I showed you before. But then here, when you click, all I have to do is increment the count on the counter model, and automatically the view will get updated. So that's the most advanced option. However, that said, all options are useful. In different apps that I built, I often will use different options depending on the situation. So it's good to know about all of them. Okay, finally, there's bidirectional data binding. So in our case before, we did not need bidirectional data binding because the button can only be pressed, and then the text can only receive changes. However, if you had a text field actually enabled bidirectional interaction, because you can enter text and you can see text that comes back as an update. So what that means is I can data bind the text of a counter to the count on a counter model, and on read, I will convert it to a string. On write, I'll convert it back to an integer. So you can use converters. That's a feature that you have when using Glimmer data binding. And then the button will just work the same way. So let me demonstrate this. It's time to do a real demo. So let's see. Actually, I have Gladiator open over here. And I believe I have that code that I just showed you open over here. There it is. So I can just launch it directly from Gladiator. So boom. Let me zoom in. Okay, so the way the button works is if you click it, it increments. But because we have data binding on both sides, the button and the text field, you end up seeing changes in both. However, if I go here now and update this to 30, it ends up updating it back into the button because of bidirectional data binding. And all of that is declarative. So bidirectional data binding is as simple as making this arrow that was unidirectional into a bidirectional arrow. That's it. Boom, you have bidirectional data binding now. But it has to happen on a property that supports read-writes. So this property is a read-write property, whereas the text property on a button is a read-only. It does not have a write because you cannot change it from clicking the button. So I just gave you a very good high overview of how to use the library overall in general. That's pretty much it. But the nice thing about it is that, let's talk about data binding now. Bidirectional syntax, you just use the double arrow for read-write properties. So read-write properties like the text on a text field, like the selection on a combo box, etc. Or you could do unidirectional binding on read-only properties. So it's like the enablement of a button is something that will only change based on changes in the model, but not vice versa. Also, the text of a label is that way. And thanks to Ruby metaprogramming, I'm able to do operator overloading on those arrows and use them for data binding to do declarative programming. The nice thing about this declarative programming is it's the simplest, most minimal code possible to describe what you want. You cannot go any less than that. That's pretty much the minimum you can go. Is I'm saying, okay, I want to bind the enablement of the button to whether the presenter of the user is logged in or not, whether a user is logged in or not, basically. Anyway, so we already saw converters. You can have an on-read or on-write converter. You can either pass it a Ruby block like that, or you can pass it you can use the symbol syntax that's familiar in Ruby. There's hooks, like before read, before write, after write. The most useful one I would say is after write. So after I write something to the model, I might want to filter and paginate the table, because this is a query term. So after I update the query attribute, I want to filter and paginate the table. That's an example. There's nested data binding. So I can data bind to the street on the address object on the company. That's called nested data binding. So it's extremely advanced. Like all the advanced features you would want in data binding are available. Nested indexed data binding. So here I'm saying I want the index 0 on the array of addresses, and then the street on it to be data bound to the text property of the text widget that we're seeing. There's keyed data binding, meaning it's a hash. So if I have a hash addresses, I want the main address. So I pass it a Ruby symbol. So it can accept, keyed data binding can accept either symbols or strings for the key of the hash. And then I could do nested and keyed at the same time. That's what we're doing here. Finally, the last thing is computer data binding. So if I have a logged out property that gets computed when the status changes, you could do computer data binding. So that way, if I change status on the model, it'll automatically notify listeners of logged out that it got changed, and that will update the enablement of the button. So to show you a quick example of that, oops. Oh yeah, here. Okay, so if we were to go login, the login sample, if I were to type something like Andy and a password, when I log in, the enablement got updated automatically here, here, and here. That's because of data binding. So if we were to look at the code, there you go. Like you can see there's unidirectional data binding to logged out, which is computed by status. So that's what caused that. So that's computed data binding. Okay, so now that we have a pretty good idea on how to write Glimmer applications, let's take a survey through all the widgets that are available in Glimmer DSL for SWT. So I'm going to go through those samples. So first sample is Hello World. We already went through that one. Okay, let's go through Hello Label, just to talk about what labels are. So, by the way, here on the top, I have the basic widget samples, and if I close this, at the bottom, I have the advanced samples. Just wanted to note that when if you play around with it after the presentation, which I highly recommend. But let's go into Hello Label. So that's the code of Hello Label. As far as label, it's a very simple widget. All it is it has a text field, and it ends up with a text value. And you can populate it any way you want. You could do a Ruby looping construct, like each loop or any kind of loop iterator, like any kind of iterator, or you could populate it a different way. And here it receives styles because it's an SWT widget. So it could be left aligned, center aligned, right aligned. You can have an image on a label. You can have a background image on a label. So, I mean, let's start looking at it. Let's start looking at how it looks like. So, I mean, these are labels that are left aligned, center aligned, right aligned, images only. There's no text. Background images with text on top of it. Horizontal labels, horizontal separator. So this separator is a form of a label. And then there's a vertical separator, which is this one. So, I mean, that's pretty much it. So right now, I'm just giving you a quick overview of all the available widgets. So let's go next. Text. Text is what you would think a text is. It's just, it lets you type. If there's no style, it ends up with no border, but you can add a border, you can align it, you can make it a password text. That's very useful. It could be read-only, so I cannot type here. It could be with event handlers that verify the data. So if I type, let's see, if I type any keys that are not numbers, nothing happens. But if I type numbers, something happens. This one is a multi-line text widget. So that's pretty much it. So again, the goal here is to give you an overview and not necessarily to have you memorize the syntax. I'll leave that to you as homework later. Hello button. Let me. We already saw one, but let me. Yeah, no, we already saw a button. I can show it one more time, but it's basically this incrementer. There's not much to it. Okay, next. Spinner. Okay, spinner is a nice one. Spinner is like text, except it's specialized in handling numbers. So if I want to display numbers, it's usually better to use a spinner. It's more user-friendly because it enables the user to do this. And you can select basically how much it increments when the user clicks those buttons. So you can provide a minimum value, maximum, the increment, the page increment, meaning if they hold page up, page down, it increments even faster. And then here you can just data bind the selection, which is the value of the spinner, bidirectionally to the donation attribute on the person model. That's it. And the rest happens for you automatically. So that's spinner. There's checkbox. Okay, let's look at checkbox. There are different flavors of checkbox. Like there's checkbox group and checkbox. They're both very useful. But I mean, checkbox is what you would imagine. It's a checkbox and it has selection, and selection data binds to a Boolean. So if I were to look at it, the Boolean, when it's false, it's unselected. When it's true, it's selected. That's pretty much it. And if I, for example, since they're data bound, when I do reset activities, it's going to trigger a controller action that will, or an implicit controller action that will tell the model reset everything, and it'll reset it back to the original value. It's assuming that snowboarding is what people like the most, whatever. That's because I'm a snowboarder. Okay, so hello radio is radio button, another very useful widget. And again, these are all native widgets, meaning any code you write using Glimmer DSL for SWT will produce GUI that is similar to code written in Swift. So if you're using Swift on the Mac, that's exactly the GUI you would get. On Windows, it's the same thing. It's equivalent of Win32 API, which is the Windows most native way of building GUI. And on Linux, it's equivalent to GTK, which is what Linux usually uses. So, so again, the nice thing about that is that the user interface is very friendly to the user and it's very predictable. And again, data binding syntax could be used just like everywhere else. Hello shell. So shell is a window, and there are many different kinds of shells. Let me demonstrate. So I have an outer shell right now, meaning it's a main shell that represents the app, but then there's a nested shell. The nested shell is nested on top of the other shell. The benefit of it is if you make it nested, you have to pass it the parent as part of the arguments. When you do that, then you can hit the escape button and get back to the original shell. This is an independent shell, so if I hit escape, nothing happens. That's just demonstrating a different option. This is a shell with a close button only, without minimize. This is a shell with minimize button only. This is the shell with maximize only. This is a buttonless shell. I mean, sometimes useful if you want to show a dialogue. This is a no trim shell. This is useful for games. If you want to build a game with no window around it even, you could do this. This is an always on top shell, so no matter what I do, it's going to be on top. But yeah, you can hit escape on all of them, by the way, and get out of them that way. And the code is just, everything is a shell. I mean, the only difference is that am I passing it the parent shell? If you do that, it becomes a nested shell. Here, I'm not passing the parent shell, so it's an independent shell. This one is a shell with a close button only. By default, you get all of close, maximize, and minimize. But if you pass an option, then you can pass minimize only, maximize only, etc. I'll leave that as an exercise to you guys, figuring out the rest. Okay, combo is like this, is a combo box. One special thing about combo data binding is that it leverages something called convention over configuration, which is borrowed from Rails. It's an idea that comes from Rails originally. So when I say here data bind the combo selection to the country attribute on person, I mean, let's first demonstrate it. So I have a country, I can change it, US, Mexico, I can reset selection, it goes back to Canada. But the key of it is it's data bound, and when I reset it, I only did reset on the model, and it automatically propagated the change to the view because of data binding. But the key thing is that how does it know that, I mean, if I'm data binding to country on person, how does it know that I have the options of Canada, US, and Mexico? It is going to know that there is a value of Canada on that person for country, but it doesn't know that these are all my options. Well, that works by convention. So by convention, if you have a country attribute, you need to provide a country options attribute as well. And the country options attribute will hold the options that are available. So in this case, it's just MT or Canada, US or Mexico. So by convention, you can provide the options of this data binding. So there are a few properties that are data bindable with conventions. Table is another one of those, which will basically, it's minimizing the code we're writing. We're writing a lot less code as a result. So let's look at list. List is, so you can have a single selection list or multi-selection list. This is a single selection list, which is very similar to combo, except they're all laid out in front of you, the options. This is a multi-selection list, so it lets me select multiple options if I want. I'll reset them. Okay. I lost my place. Okay, table. Okay, so table is one of the most sophisticated widgets out there. This is a table. You can do a lot of things with tables. You can add images next to each cell. You can have, if I book this game, it becomes colored green. And then I can switch. I'm doing something called here, not nested data binding. This is called master details data binding, meaning I have a data binding on the combo, and this data binding will affect the data binding that's secondary on the table. So it'll show me different data when I change the options on the combo. So they call that the master details pattern. It's a very common pattern in desktop applications. So that's one way of doing it. Another way of doing it is instead of using combo, you could use a tree, which I'll demonstrate soon. So tree is next. Oh no, not next. Okay, refine table. Refine table is a new custom widget that I added to Glimmer DSL for SWT because a lot of people ask for filtering and pagination when working with table data. So this gives me a table that is automatically supporting filtering, so I can support by all Red Sox baseball games, for example. This is a game schedule. Or I can do pagination. Or I can type in here the page name, like 50, enter, etc. So it gives me all of that for free out of the box, including sorting even. I get sorting for free as well. So you get all of that for free just by using refine table. As far as the code, whether it's a table or a refined table, the data binding happens through this statement, which basically, actually, I don't even need the last part. Like if I delete that part, this should be enough. So by convention, I'm data binding to all the games that are on the baseball season object, and it'll figure out all the attributes from the game object that map to the table column names. So if I have date, ballpark, home team, away team, it assumes you have those attributes on the model. So by convention, it'll pick up all of those attributes from the model and fill the data for you just by typing that tiny short line of code. Unlike, say, when I did this in Java in the past, I had to type pages of code before I could populate the table with data. I had to use something called a viewer, which here is not even needed. Okay, hello tree. Let's look at tree. So tree is the second, I would say, most important widget for business apps. So here we have a company hierarchy. We have a CEO, CTO, CFO. Under the CTO, there's a VP engineering, there's a director engineering, manager engineering. It's a very large company. And finally, a senior engineer like me, a mid-level engineer and a junior engineer. And then this is a master details view as well. So if I click on this, it changes the data here. It changes all the data binding on this form. So now I'm data bound to the values of Stephanie Davis, and I can, for example, increase the salary, and it remembers it. If I go here and come back, it remembers it. So that's tree. For tree, the data binding is very similar to table, except actually you need one more piece of information for tree. You need to figure out how to iterate over every child of the tree to pick out the children of it. And to do that, let me see, where's tree? Okay, there's a tree. So the tree items are data bound unidirectionally in this case to the CEO at the top. So you need to just give it the root at the top of the tree. And then here in tree properties, you need to give it what is the method that you use to pick the subordinates. It's just subordinates in this case. And then what is the method you need to use in order to convert every child into a piece of text that you can display in the tree. And here it's just the Ruby 2S, nothing special. So that's pretty much it for tree. Hello style text. Style text is the widget we're looking at right now over here. This is a text that is tiled, meaning different parts of the text have different colors and different styling. So let me show you another example. It's basically how you build word processors. This is like how to build Microsoft Word, basically. You use this widget, style text. You can do underlining, you can do highlighting, you can do bolding, strike throughing, etc. So that's just style text. And it works almost exactly like text, except it gives you a new listener called online get style that will let you populate the style for every line, which you can check on your own time. But there's a specialization of this widget called hello code text. Hello code text actually does the same thing, except it automatically styles code. So you just give it the name of the language you're using. So in this case, for example, let's see. I have a code text widget that takes a language of Ruby, and then I populate its text with data binding, the same way you do it anywhere else. And then when I launch it, it gives me Ruby syntax highlighted code automatically. And this is what I used in order to build Gladiator, the Ruby code editor that I showed you earlier. So it supports JavaScript, it supports HTML, etc. You can build your own themes now. There's support for building your own themes if you want. It comes with a few themes out of the box, but you could also build your own themes. I have a blog post about how to do that. That's pretty much it. You guys just got a quick overview of all the widgets. So, okay, the next set of widgets is organizational. Composite is a widget that lets you fit multiple widgets underneath and then lay them out either horizontally or vertically or in a grid. That's what composite is. Scrolled composite just adds the scroll bar. Sash form, let me show you sash form. We already have a sash form here. Sash form lets you separate two areas and then resize between them. That's pretty much it. They call this a sash. There's hello group. Group is what you're seeing here on the screen. We have a gender group and an age group. Hello tab is basically tabs. Let me show you that one because it's very useful. So I have hello world done in two languages, English and French. So these are two tabs. Hello toolbar. Toolbar is what you see in Microsoft Office applications often. So like cut, copy, paste, like you have a toolbar with icons. The icon resolution I have here is a bit low, that's why they look ugly. You can make them look nicer if you have nicer icons, but that's pretty much a toolbar, kind of like the toolbar you would see in a Microsoft Office app. Or there's something more advanced, which is called the cool bar, which is the next complexity. So a cool bar is formed of multiple toolbars. So here we have two toolbars. We have this one on the left, and then we have this one on the right. This one is cut, copy, paste. This one is font size. The key thing about toolbars laid within a cool bar is it gives you this resizer that lets you resize them or move them around like that. Kind of like in Office applications as well. Okay, what else do we have? Tray item. Tray item is interesting. So tray item is basically showing an item here in the tray at the top right corner. And on Windows, usually it's at the bottom right corner, but let's launch the tray item app. So I just launched it and it added this extra icon over here. And now if I want, I can close it, but it stays open. So if you want to keep an app in the background, you can do that using a tray item app, and then I can click show application and it shows it again. So that's just a tray item app, which could be useful if you want to keep something in the background. Whoops, I actually exited Glimmer samples, no big deal. Okay, hello menu bar. So a menu bar is what you see here. It's what you see here in the menu bar. So I'm going to be launching an app that will demonstrate that clearly. I don't know why it zoomed in. Oops. Doesn't matter. So let's do hello menu bar. Okay, I just launched a menu bar app, and if I were to drag it here, it gave me all of those menus. So all of those menus came with it. So I have a file menu that has standard file menu stuff. I have an edit menu, options. I can enable the options and then select either one. So this is kind of like a radio. This is multiple, so it's kind of like checkboxes. I can do image menu items to change the language. I can change the country with an image and a word. I can change like the background color, yellow, and foreground, etc. And then I could do a view here. And then finally help. So this is a way of doing menus in apps, which is a very common thing. The second kind of menus is pop-up menus, which is if I right-click on a widget, it gives me a menu, and then you can, then you can add a whole bunch of things to it and perform actions when the user clicks one of those menu items. That's pretty much it for organizational stuff. Finally, it's dialogues. So message box, you guys already saw an example. Color dialog for selecting color, font dialog, file dialog, directory, print, and a general dialog. General dialog, you can put anything in it. Anyways, let's move on next. Okay, so next thing is another advanced topic, which is canvas graphics. How do we build non-native widgets? If I had a brand new concept that does not have a widget already, how do I build it? Let's just say I want to build a UML diagram designer. How do I do that? Well, I can use canvas graphics, and you can use in it the following shapes out of the box, like point, line, rectangle, oval. You can see them here on the right side. Arc, polygon, polyline, image, or text. If you want a shape that is not any of those shapes, what you could do is do something called custom shapes. You can build your own advanced custom shapes out of those shapes. So you can compose more complex shapes from simpler shapes as well. So canvas graphics lets you do things like that. So obviously, it helps you with building things like UML diagram designer, or you can build games with it as well. This is how you build games. So there are a whole bunch of samples for it. Maybe I'll just demonstrate one of them. Let's see. Hello Canvas drag and drop is interesting. So this is just painting a bunch of circles in a rectangle here. I can just drag them. And when I drag them, it copies the value that's within it and adds it to the value that's here. So now it's 10, now it's 14, now it's 21, etc. So I mean, that's showing you a custom app with non-native graphics, or basically custom graphics, or they're also called canvas graphics. There are a whole bunch of samples. I'll let you check them out on your own. But okay, next topic is custom components. So custom components is you building your own custom widgets, kind of like how I built code text as a custom widget. So you can build your own custom widgets as well. So a custom widget is usually, will mix in Glimmer UI custom widget module. It accepts options, and it's useful for one of three things. Either specializing a widget. So if I want to provide a label that's always red, because I want to use a red label on certain things, you can create a widget called red label and just use it. And it's pre-specialized for your needs. You can do aggregation of widgets. So that's if I build a name and address form and I reuse it multiple times in an app, that's an aggregation. And the third concept is, for example, the code text widget, which it does syntax highlighting for programming languages. That's a specialization of style text. So that one is the first case. The other one, refined table, which I already demonstrated, that gives you pagination and filtering, that's an aggregation. It aggregated a whole bunch of pagination buttons in a filter text field in addition to a table. So that's an aggregation custom component. The third case is building brand new concepts like an oscilloscope, like this one, or like the Gantt chart, or like a watch, like a clock. So this is how to build non-native widgets. The second type of components that's custom components is custom shells, meaning custom windows. Basically, all apps are custom windows. When you build an app, it's a window that has its own things that are unique for that app. So when you build an app, usually you want to mix in a Glimmer UI application, which is an alias for custom window or custom shell. And not only that, if I build an app like Gladiator, automatically for free, when you build it as a custom shell or custom window, it becomes a reusable widget as well. Meaning I can fire up a different app that is called whatever, my Lexop business app. Let's just say I launch it every day. It shows me my contacts at Lexop. I can add a button to it that would automatically open Gladiator as well as just a custom window in it as a custom component. So you can reuse apps within apps basically automatically by building custom shells or custom or apps. Another example is building a window that shows you the email content of an email. And I mean, to do a quick demo of that, custom is here. Custom shell. Okay, this is like an email client. We have a window here, and then I can click one of those and it reuses this window. So every time you want to display an email, it's always the same type of window that shows you the metadata on top and then the body on the bottom. So that's a custom shell or custom window. The third thing is, the third type of custom component is custom shapes. Custom shapes is what I mentioned earlier about composing simpler shapes into more advanced shapes. And that way you can build games, for example. I can build a stick figure that I can reuse in different sizes and colors. I can build playing cards and just reuse them in Klondike Solitaire. Like these are all playing cards. Or I can, this game Quarto, let's see, I have Quarto here. Quarto is one of the newer games that I added. But yeah, it has all of those custom shapes. By the way, anybody played this game before? It's a real board game. It's kind of like the more advanced version of tic-tac-toe, like a much more interesting tic-tac-toe. Like you have to hand a piece to your opponent, and then he has to place it somewhere, and then he hands you a piece, and then you need to place it somewhere, etc., etc. And you need to form a line based on either color, height, or shape. So this is built with the Canvas graphics. This is a very good example of that, and it uses custom shapes. And the nice thing is not only did I build those custom shapes like cylinder and cube, I also extracted them into their own gems. So now anybody can add a cylinder or cube to their app by adding those Ruby gems. Okay, so that's pretty much it for custom shapes. They support relative positioning, by the way, so they work so much like SVG. In SVG, usually you have a component that includes multiple smaller, other shape. You have a big shape that includes smaller shapes within it, and it's an aggregation. This works very much like SVG. So if you've ever used SVG in web development, this is very similar, but in Ruby, in pure Ruby. Drag and drop. Okay, I'm just going to give a very quick highlight of drag and drop. So the key thing you need to know about drag and drop is usually you have a drag source. So you need to activate the drag source property to true. And then you need to designate something else as the drop target. So for example, here, every label is a drag source and a drop target at the same time. Here we have a text widget that's draggable and a text widget that's droppable, or a drop target. So, and when you drag it, it'll automatically copy the data for you in Glimmer. That's it. That's all you have to do for the basic drag and drop support. If you need more advanced support, like I'm moving a file here or I'm doing something crazy, you can listen to listeners, like on drag detected, on drag started, on drag set data when it starts, on drop, what to do on drop. And within those listeners, you could do some work that would occur when you drop something. So, I mean, to give you an example, if I were to play Klondike Solitaire, for example, let's see, if I drag this and drop it here, in the on-drop action, I basically interact with the model layer and I tell them, move this card from this pile into the other pile. And once the model does it, since I'm following MVC, the view will automatically refresh itself from the models and update itself because I'm following MVC correctly. So this all happens because of using the on-drop action. So that's pretty much it for drag and drop, but obviously there are more nuances which you'll learn if you look into once you study all the samples and do the homework. I mean, hello drag and drop, I don't have to demo it because you guys are seeing it on the right side here. That's pretty much hello drag and drop. Okay. Hello Canvas drag and drop, we already took a look at it. This is it. It's a little different with Canvas because with basic drag and drop, you're dragging data that is usually a piece of text. Like when I had a list, see, I'm dragging a word from this list to this list. Whereas with Canvas, there isn't necessarily a text, it's just a concept. And then you can give it any meaning you want, and you have to do extra work in the on-drop listener to do that. Or in the models, actually. If you're doing clean MVC, do it in the models. There's also something called drag and move, which you can make anything movable if you want automatically by using drag and move property, but not necessarily movable for dropping, it's just movable. So that's something you get for free. Anyways, let's get into the final parts of the presentation. So how do you build an app from scratch? So the best way to do so is to use scaffolding, which is very similar to how Rails works. Again, this is an idea borrowed from Rails. It's good to reuse good ideas. So I like the idea of scaffolding a lot in Rails because it helps you get started very quickly. And Glimmer, it's the same way. You can scaffold an application with this command. Glimmer scaffold app name, that's it. In fact, while I'm talking about the other options of scaffolding, let's scaffold an app. I already have an app that's scaffolded, but let's scaffold another one just in case. Let me make sure that I have the Glimmer command here. Yeah, I have it. Okay, good. So Glimmer, scaffold, and greeting. I'm going to call it greeting. And I'm going to run it. Okay, while it's scaffolding, let's talk about the rest. So you can scaffold a custom shape, like I mentioned. So that'll build the class for how to build a custom shape automatically for you with all the skeleton, and then you just fill the rest later. At your convenience. You can scaffold custom windows or custom shells, custom widgets. You can desktopify, I'll get into it later. You can scaffold custom shape gems. So if you want to build a gem and then share it with other people that has a custom shape or custom shell or custom widget, you can scaffold the entire structure of the gem, and it'll give you a very simple command that you can run at the end once you implement it, and it'll package it as a gem, and it'll help you publish it as well. By the way, the app that I just scaffolded finished, there it is. It's just hello world. That's what you get for free by default, and I can even open the preferences, and it gives you an example of how to implement preferences, and it now changed it to how do you partner. So what do you get when you generate an app? It generates a full app when you scaffold. The models live under app name, model. The views live under view app. So app name is used as a namespace. So if my app is called greeting, it's going to be app greeting model and app greeting view. It's just a Ruby namespace. The app can be run either with a bin script that matches the name of the app. Actually, this should have been bin/app name, or by running Glimmer run. So let me show you an example of what I'm talking about. So I just scaffolded this app greeting. It's inside here, greeting. I can type in Glimmer run, and that will run the app. So that's one way of running the app, is Glimmer run, there it is. Or I can type in bin/, and it gives you a script for free that matches the name of the app by convention, and gives you that for free, and it launches the app. The code, take a quick look at the code. So there it is. So I have this scaffolded over here. So if I were to zoom in here, there it is. I have app, I have greeter, and I have model and view. Greeter is a different one that I scaffolded before the presentation, but it doesn't matter. It's the same thing. It gives you an app view by default and a few extra launching scripts and namespacing files. But this is the key file, is app view. That's the entry point. It basically includes a Glimmer UI custom shell because it's a custom window. There are things that I didn't talk about, but you have support for how to specify options for the app if needed. Usually it's not needed, but you can take advantage of it when needed. This is before body is a hook that executes code before building the GUI body, and then the GUI body goes into this body block, and then within it gives you a shell with a minimum size, an icon, image is the icon, a label, and a menu bar. So it gives you an example of everything, how to build a menu bar, how to make preferences. So here at the bottom there's a preferences dialog. This is the preferences dialog, display preferences dialog. It gives you examples of everything so you can get started with it basically. And you'll end up with a menu even. So let me launch it again. So here I have a menu. You get this menu for free, like a file menu. It's a very common thing in a help menu. So that should help you get started very quickly. That's pretty much it. But the next interesting part, or most interesting part, is how do we package the app as a native executable and give it to people so that they can install it on their machine. For example, like when I launch Gladiator, I have an icon for it here. I can just click on this icon. That's how I launch it. So how do we install that icon? How do we provide an app like that? So what you do is you run Glimmer package. And if you're on the Mac and you want it to be a DMG, you say DMG. because you can also package as PKG, which I'm not personally a big fan of it, but some people prefer it. Anyway, so if I run this command, it's going to do a bunch of things before it gives me the package. But let me show you another package that I prepared before the meetup. Let's see, code, greeter. No, not greeter. Greeting. Never mind, I must have not prepared it. So let's just wait for this. So on Linux and Mac, it'll work out of the box. On Windows, it'll require you to install libraries. Oh, there it is. See, it packaged it as a DMG installer, which is the typical Mac installer. So let me show you how it looks like once I open it. So it ends up under packages, and I can go here now, and then under bundles, I go here, and there it is. So now if I click this thing, it gives me an installer, and here it puts your license. So once you add a license to the app, it'll show up over here. So it's totally official. Then I can click agree, and then it gives me this. And the icon, this is an icon that I give you for free, but you can actually add any icon you want. So for Tetris, it'll show the Tetris icon. And all you have to do is drag this to applications, and now it's an official Mac app, and nobody will know ever that it's written in Ruby or JRuby or Glimmer or any of that. So here, now I can just go to applications here and run greeter or greeting, sorry. And I just open it and it should show up at the bottom. Whoops, there it is. Boom, there it is. See, that's a native app now. It's no longer just Ruby code. So that's pretty much it. So you get DMG files, PKG, on Windows MSI, but you need to install the Wix tools in order to get that before you do it on Windows. So only on Windows you need the prerequisites. On Linux, like Ubuntu, you get DEB files. On Red Hat, you get RPM files out of the box. So that's pretty much it. So yeah, I mean, that's pretty awesome because that's what Shoes in the past provided. So this gives you everything that Shoes didn't provide in the past. But Shoes is a lot less advanced than Glimmer. Shoes doesn't give you data binding. Shoes doesn't give you table widget. I don't believe they support table or tree, unfortunately, unless you hack your own custom code. So they look kind of ugly and non-native in Shoes. So I mean, Shoes, think of it as a very, Shoes was just an educational tool, whereas Glimmer is the real deal. It's a real business app development library that performs, in my opinion, more productively than any of the Java ones out there, or Swift or C++. Again, we looked through Hello World. I was thinking at the end I could go into the code of each one of those and dig into them, but I think I'll just leave it as an exercise to you guys to do it. In fact, I have a lot of blog posts about them, so I'm going to share with you links with my blog post in it. You can read blog articles about how I built Tetris and about how I built this one, Contact Manager, etc. So I don't have to go through it, but let's give you a summary of the talk. So basically, we talked about why we want a native GUI. We introduced a few GUI samples. We jumped into real-world apps like Math Bowling and the DCR programming language. I talked about the basics of the Glimmer GUI DSL. Then I went through software architectures and data binding, like MVC, MVP, and like bidirectional, unidirectional data binding. We talked a little bit about, I gave you a survey of all the widgets, and then we went through Canvas graphics. And finally, after that, how to build custom components, how to do drag and drop, how to scaffold an app from scratch, and last but not least, how to package an app as a native executable. So that's pretty much it. This is a JRuby library. That was the very first Glimmer library that was built. Eventually, the idea became so interesting and applicable that it became a good idea to apply to CRuby as well. So the most complete CRuby flavor of Glimmer is called Glimmer DSL for libui. That's the one that got demoed to Mats, the creator of Ruby, early this year and won the award. So you guys, if you like the JRuby version and you want to use CRuby, check out the Glimmer DSL for libui. It almost has all of the features of Glimmer DSL for SWT. And I continue to update it to make it match it feature by feature for feature, but right now it has about, I would say, 80% of its features. including bidirectional and unidirectional data binding, which, by the way, that is the reason why I won. Matt's told me that was the most interesting thing in the project, is the data binding part. And there are many other flavors that are based on other toolkits. So I mean, in my mind, I thought, why not support all the Ruby available toolkits? So Glimmer now supports them all. There's libui, there's TK, which is based on TickleTK. There's GTK. You can use GTK from Ruby with Glimmer. There's FX, there's Swing, and there's JavaFX. The last three are the least developed. Like, they were only a few days effort of an alpha at an alpha project level right now. But still, they're a good start. If somebody needs help with them or needs further development, just hit me up and I can develop them further. And these are the useful links that you want to keep track of. And we should be posting the presentation slides in the end on the meetup.com page, but these are the links for the project, my GitHub account, my blog, Twitter account. YouTube is interesting because in YouTube I have about 36 tutorials of how to use Glimmer DSL for SWT. It covers pretty much all the features right now, except scaffolding. It's almost complete, the series, and once it's completed, hopefully I'll move on to another GUI toolkit from Glimmer. But yeah, other than that, we are hiring at LexUp. So we're looking for Ruby on Rails software engineers. So if you're looking for a job, please apply. And I guess we'll move on to the Q&A. Go ahead.
What about performance? Because I'm very impressed by the ease of writing, and to me it sounds kind of like too good to be true. So is there a performance drawback or a?
Not exactly. So once you launch the app, there are no performance drawbacks. In fact, I did list in the initial slides that because the GUI is native, it has native performance. So the GUI itself will run natively. Awesome. It will not freeze because it's using SWT, which is written in Java on top of C++ and C, which basically the GUI is independent of any Ruby related memory management. It's not affected by it. However, launching the app is a bit slow. It takes 2 seconds on this Mac. 2 seconds is fast, actually. 2 seconds and a half, sorry, on this Mac because it's an M1 chip. It'll probably take even less time on the M2 chip. But on older computers, it's a bit slow because it's JRuby, which has the Java startup time as opposed to the Ruby startup time. That will improve continuously. But today, the biggest improvement is that on M1 and M2 chips, it runs in about 2 seconds, which is tolerable. Mm-hmm. Hopefully, it'll get faster even on all the platforms eventually, because the JRuby team is always enhancing JRuby. But one thing I wanted to say is the reason why I ended up exploring C Ruby gives you all the benefits you guys just saw with an instant startup time. Whoa. So Glimmer DSL for libui starts instantly. However, SWT is the most advanced toolkit library of all of those. It's, in my opinion, it's the most superior. GTK might be the second most superior, but GTK unfortunately is only good for Linux. It's not on the Windows. It doesn't give you native widgets, whereas SWT gives you native widgets on all platforms. That's why it's the best. libui is like aiming to become SWT using C Ruby. libui also gives you native widgets on all platforms, but it's a very underdeveloped toolkit at this point. It's only at Alpha 5. And they're working very hard on it to make a release very soon. In fact, I've been communicating with the C library toolkit authors quite heavily lately because I want to make a new release. Awesome. So hopefully this will become the future of Glimmer.
Cool.
Any other questions? Yeah.
Thank you, first of all.
You're welcome.
Impressive.
You're welcome.
I fully understand why you want the price. How's your flow when you want to debug? When you want to see why the variable is not instantiated or so on? Like in typical web development, we would look at the console, we would have an output. Mm-hmm. Do you have a console? Can you jump in and introspect? Is there a debug mode? I don't know. Or how do you do usually? I'm
pretty sure you could use a debugger if needed, but I personally never ever use a debugger. I use my own library. I don't know if you've heard of it. Puts debugger. It's based on a blog post by Aaron Patterson, you know, the Rails contributor. He wrote a blog post that was very funny a few years ago called Puts Debugger, and then I built a library based on it. I'll show you what I'm talking about in a second. This one, I am a Puts Debugger, and then I built a library. So let me show you the library though. It's just a library that will let you, when you say PD in a variable, it not only does it print the variable, but it gives me the line number and the file name, so I can track what's happening where in the program. I personally just do all my debugging with this, and I'm pretty happy. But also desktop apps generally, in the C Ruby versions, they start instantly. So if you change the code and start the app again, that's fast enough usually for most users. In JRuby, what I do is, because there's a JRuby startup time, what I do instead is I use Gladiator. Gladiator lets you run apps. So I showed you guys already how I ran an app from here, like this one. I just ran it. See, it runs instantly. So as long as you're within an app that is written with Glimmer DSL for SWT, you can actually debug and rerun your apps instantly. And to me personally, I find that good enough. I have not explored debuggers just because I'm not personally a very big fan of them. But if you are into debuggers and you want to use it with Glimmer DSL for SWT, then you are encouraged to do so and then blog about it and help others learn how to do that too.
I think your method would be satisfiable to me. I mean, basically, you can create a text field and put the values of all your variables with data binding if you want to, and follow along.
Yeah, I mean, even this, the Glimmer meta sample, which ships for free with Glimmer DSL for SWT, it already gives you part of Gladiator. It gives you part of the editor without all the sophisticated features of Gladiator, but it gives me an editor. So here, I already guys showed you how I can do, like window, open. It starts instantly, and then I can adjust it, like do here, this, and then text, Glimmer, adjust it. So that's, to be honest, that works pretty well for me. It works well enough. I mean, when I built that metronome that I told you guys, I built it in 10 minutes. Seriously, that's what I was doing, and it took me 10 minutes. I mean, it took me an hour to fine tune it, but 10 minutes for the initial version, for the MVP of it. So yeah.
It's a different workflow, basically. You don't need test suites. You don't need a bunch of things.
No. No. But the nice thing about following MVC and MVP cleanly is the model layer is completely decoupled from the view. So yes, I do write tests for the models. Okay. So when I built tic-tac-toe here, I have a tic-tac-toe game. Where is it? I built it test first. So I wrote all the logic for figuring out when the game is over by writing purely model tests, and then I wired the view layer on top of it. And given that I can observe any model attribute without having to change the model, I honor the open-close principle. So that means the models stay the same, but the view can augment it with a GUI.
Cool. That makes a lot more sense. So you do have tests, and
sometimes. I mean, I use them judiciously, but yes, I wherever I feel like they could be really helpful, I do add tests. Yes.
But what we don't have is a way when the application is running to go in back and basically on Solitaire say, hey, you know that second card on the second, what is the value of that card?
That's what I use Puts Debugger for.
Yeah, exactly.
PD.
If you put it before and you relaunch the application, you can, but you cannot introspect.
What's nice about PD versus Puts is Puts doesn't tell me where that variable was printed from. So if I just do Puts debugging, that's not good enough because it'll print the variable value, but I have no idea where that print statement came from. But if I do PD, it always gives you the file name and the line number. So I even use that in web development, to be honest, in Rails, and it works pretty well for me.
Cool, thanks.
Any other questions? I have a question. Who here has a desktop development experience? Oh, not much.
A little bit, but
what did you build?
it was mostly for school projects and everything. We're using C# and Java.
Okay. Yeah, that was one of my earliest experiences too. I used Java Swing back in the day when I was in McGill University. So what sort of apps did you build? I'm curious.
One of the most complete app that we made was kind of a movie database where you could put you link an image and it would detect the the cover, like the DVD cover or whatever, you link it to it, and it's gonna like use image recognition and like give you the movie, and you can search it and click on it and start watching it.
Nice. So did it use an online element too? Like, did it hit the web?
Yeah, for watching.
Oh, it's pretty cool. Awesome. So now your assignment is to rebuild all of that in Glimmer with like 1/10 of the code. No, seriously, because I write about a fraction of the code I used to write in Java with Java Swing, for example. So, anyways.
Also built image like Photoshop or whatever.
Mm-hmm.
Picture editor.
Awesome. One thing I want to conclude the talk with is all of the skills that you guys just learned about MVC and MVP are transferable to the web. What I like about programming Glimmer as much as I could is it helps me become a better web programmer, because every once in a while I'll think of an idea and I'll be like, why don't we do this on the web? And then I try to do it on the web and then I end up with less code even in web development. So it's always good to sharpen your skills with desktop development in addition to web in order to become a better overall developer. But yeah, that's pretty much it. Thank you guys.
Thanks.